Somewhere on the African continent, between 930,000 and 813,000 years ago, the human story almost ended before it began. Not in a single catastrophe, not in one terrible night, but across more than 1,000 centuries, while our ancestors clung to existence in numbers so small that geneticists today still struggle to believe what they found. At one point, the entire breeding population of the lineage that would become you was around 1,280 people, not 1,280 settlements, not 1,280 family groups, 1,280 people. Total, a single modern high school has more students than that, and this wasn't a temporary dip. This number held generation after generation for over 100,000 years. This isn't a theory from a textbook you half remember from school. It's a finding from 2023 that most people have never heard. And the deeper you go into how scientists found it, the stranger and the more unresolved it gets. Here's the part almost nobody mentions. This number didn't come from a single bone, footprint, or skull. No expedition unearthed it. No fossil bed confirmed it. It came from something far stranger, the DNA of more than 3,000 living people walking around today. A team of researchers built a method called FITCOL, short for Fast Infinitesimal Time Coalescent Process. Think of it like this. Every mutation in your DNA is a kind of fossil too. Not buried in rock, but buried in your cells, inherited copy after copy, generation after generation, all the way back. By tracing the mutations in genomes sampled from 50 different populations across the globe, 10 African, 40 non-African researchers could rewind the tape, not metaphorically, mathematically. And when they did, the population size curve didn't just dip, it nearly flatlined. Important detail here because this is where most coverage of this story gets it wrong. 1,280 is not a head count of every human alive on Earth at the time. It's what geneticists call effective population size, the number of individuals who are actually breeding and passing on genes. The real number of living bodies was likely higher. But here's the unsettling part. Effective population size is actually the number that matters most for extinction risk. It determines how much genetic diversity survives and how close a species really came to disappearing for good. A small, effective population doesn't just mean fewer people. It means fewer chances, fewer combinations, fewer paths forward. Ours nearly ran out of all three. You'd expect a number like that to come from a single disaster, a flood, a famine, one terrible season. It didn't. The bottleneck lasted roughly 117,000 years. Let that sit for a second. Homo sapiens as a species has existed for roughly 300,000 years. This near-extinction event lasted over a third of that entire span, a stretch so long that thousands of consecutive generations were born, lived, and died without ever knowing their species had any other way to exist. No one inside that window knew they were living through humanity's closest call. There was no before. For over 100,000 years, this just was what being human looked like. Here's the number that should genuinely unsettle you. Researchers estimate that as much as 65.85% of ancestral genetic diversity was lost during this period. Not 65.85% of people. 65.85% of the genetic variation itself, gone. Erased before modern humans even existed. Every trait, every combination, every possible version of human that could have branched off from that diversity, most of it never got the chance. Every population, every person alive right now descends from the surviving sliver of what used to exist. We are, quite literally, built from what was left over after the bottleneck nearly finished the job. This story doesn't stop with genetics, because the DNA wasn't the only thing pointing toward an ancient population collapse. A completely different field, one studying bones instead of genes, found something remarkably similar. For decades, paleoanthropologists noticed a strange gap in the human fossil record. Around the same period, African and Eurasian hominin fossils suddenly became much rarer, fewer skeletons, fewer archaeological sites, almost as if humanity had quietly faded from the landscape. What's remarkable is that the genetic researchers didn't start with the fossil record. Their calculations came entirely from modern human DNA, yet when they estimated the timing of the bottleneck, it landed almost exactly where the fossil gap already existed. Two completely independent lines of evidence, one hidden inside living DNA, the other buried beneath ancient rock, both pointing toward the same mysterious period in human history. Neither field depended on the other, yet both arrived at nearly the same conclusion. That doesn't prove exactly what happened. But when two completely different scientific methods begin telling the same story,